3 and 4.
3 and 4. That seems to be general consensus.
1.
Okay. Alright, with number 3, we need to put each of these values in for x and find the range values for each of these. So I would start with -2, f of -2 equals 1/2 times -2, use parentheses, squared, -3 times -2 plus 1. So that this would become a positive 4 times 1/2. This would become a positive 6 plus 1. So this would become 2, and this is 7. So 9. And then you would do the same thing for 3 and for 8. We'll just write that down here. So this would give me 1/2 times 9 minus 9 plus 1. This would give me a decimal for 9/2 or 4.5. 4.5 or 9/2 plus minus 9 would be -4.5 or -9/2 and then half one. So -3.5 or 7/2. And then the last one. So in that one, 8 squared would give us 64. This would be 24. Half of 64 is 32. This would be -23. And then that would be 9. Yeah. So then we would write that least to greatest in curly brackets. And since 2 of these answers give you the same number, you would only list that once. -3.5 or -7/2 and 9. And you could have double checked in your calculator those same things. Questions on any of those? Or was your challenge question? If you got it, great. If you didn't, that's fine. Okay, so first it says if h of 1 equals -5, then it says find h of -4. So 1, if you have a missing variable in here, we have to find k before we do anything else. So you would set this equal to -5 and put 1 in for all of your x's. And this is going to help me solve for k so that I can go back and find h of -4. So this would give me -5 equals -2 times 1, which is just -2. This is just k plus 5. I can combine these like terms to get 3. And then subtract 3 so that k equals -8. And once I have that piece, go back, put that in, and find h of -4. I'll do that over here. This plus 5 at the end is just cut off. So So then when I have that k value in there, I can look at each piece. This would give me 16. This would give me a positive 32, and then that plus 5 at the end. This would give me a negative 32. The 32s will cancel, just leaving 5. And again, once you've found your k value, then you could have put that into the calculator and double check that. Questions there? So, as I mentioned last class, today is going to be the last lesson in Unit 4, but we broke it up. We quizzed and tested the first 3 objectives already. Now we're going to talk about the last one. We are going to take a quiz on that next class, and then do a project on that the class after that. So everyone should have notes that look like this. So notice the different objectives. It's a lot about line of best fit, regression methods. You'll hear those words a lot. But we're going back to scatterplots just for a bit so we recognize what we're doing, what we're using, the different types. So let's go through vocab really quickly. Scatterplots are used to determine whether or not two variables are related. A trend is when a change in one variable affects the other. In real life, trends can help us make sense of the world and help us make predictions. I'm going to have you fill in this blank. A blank trend occurs if one variable increases when the other increases. Kind of positive. This trend is much like a positive slope. A blank trend occurs if one variable decreases when the other variable increases. Negative. This one is much like a negative slope. And then the last type, there is blank between the number of newspapers and the temperature in the following example. You remember the other type. No correlation. Why did I write? I did. Yes, it's 2 R's. Yes. Okay. On the back, all of those words are given to you in a table so that you forget. You can refer back to them while you're practicing. Another term used to describe two sets of data that have a connection or relationship is a correlation, is the word for both of these. So correlation can be positive or negative. We talked about that. It can also be strong or weak. We talked about that previously as well. And there are some different examples of those. So keep in mind that trend and correlation are interchangeable. So if you see one, don't get confused by that. We're not going to do a lot of the practice with scatterplots, but it is there if you need to go back and practice with that. But go to page 4, the back of the next page. And we'll just go through a few of these and then move on. So keeping in the context, if I said the number of hours a person has driven and the number of miles driven, do those increase together? Do they decrease together? Does one increase and one decreases? They both increase the number of hours a person has to drive and the number of miles driven. They both increase, which means it's positive, negative, or no correlation. Okay. The number of siblings a student has and the grade they have in math class. No correlation. They have nothing to do with each other. You know, apply this to the world, sure. Not logic and math, because that's something else, but sure. The age of a car and the value of a car. Negative. Because usually they're both going down. Usually the older a car gets, the less it gets. So negative, yes. We'll do one more. The number of years a person went to school and their income. Positive. Usually, typically, the more years you went to school, usually you have a higher income, but that depends on your job salary. Like, I was in school for 4 years. There are other teachers who went to get their master's, doctorate. So they have more money, yes, because they went to school for longer.
How many years is a doctorate?
Because it's bachelor, I forgot one second one. The master's, thank you, which is usually just 2 more, but sometimes it's 4, it depends on the program. So that's 6. I lied, it's not 12, so I want to say the doctorate is just additional 2, but it could be 4. It depends. When Hasi gets back. That's like your doctorate. But it also depends on the field. So like people in medicine go to school for ever. Alright, on to the next page. This is where we're actually going to get into what we're doing. So I'm going to show you how to do this on the calculator. First, we're going to go through a little bit of review real quick. Then I'll show you how to do this on the calculator, and I'll show you how to do it in Desmos. And then for the quiz, for the project, you will have a choice whether to use Desmos or the calculator or both. Alright, so we were just doing stuff like this with our function notation. So in that, disregard the number. If I had an x value of -2 and I wanted to find the y value, I would put that in for x and figure out what y is. So that would be y equals 3 times -2 minus 4. And then I would figure out what 3 times -2 is and then subtract 4. So that would give me -6 minus 4, which would be not 2. This is -6. -10. Okay. Do the same thing for the rest of this table. Put in that x value. Find what that y value would be. What would this one be? I would. -7. If I put in 0, what would that y value be? -4. If I put in 1, -1. And then if I put in 2. So as we're getting into the line of best fit, the linear regression stuff, you'll start to see patterns, recognizing different patterns. So in this, based on the slope, I can tell that this is going up by what? 3 each time. And the slope kind of helps me figure that out. So with our graphs, our lines, that will also kind of help us do that. I'll leave that one. If you want to do that one, you can do that later. So when we were doing scatter plots, we were plotting a bunch of random points, looking at the correlation, how are they related to each other, the association, all those things. Now we're going to be finding an equation, a line, that best fits this data, that goes through a good majority of the points or surrounded by a good majority of the points. So we're going to use this example. So before we do anything, on the calculator, everyone should have their calculator, reset it. Second plus 712. Second plus 712. That way we're just all starting with a fresh start. There aren't other things in there that we have to worry about or anything. It's also up there in pink. Okay. If you get lost at any point in time after I repeat this step one more time, all of the steps I'm about to say are listed for you in your notes.
My favorites are
Make sure your batteries are in.
Oh,
Okay.
they were all in.
Alright, now we're going to go into stats, which is right next to the arrows. I only press one button, guys. Check your calculator pocket. If it's not there, I have another one. You should be on the edit screen. Press enter or 1. And then the table that's given to you on your notes, we're going to put that into L1 and L2. So before we do that, looking at your notes, this example is given time in hours and the grade. So does the grade depend on the time or does the time depend on the grade? Grade depends on the time. So that means the time is our x and the grade is y. Usually time in general is x because we can't control it. So we're going to put all the x values in L1. So you can either type it and press enter, or you can type it and go down. Fill out your x values. If you arrow over to the right, it will let you start putting it in L2.
How do you go to the next one? Oh, no.
Arrow. There you go. Okay. After you have all of that data in, we're going to go into step 2, which is at the bottom. Now, the side notes here. If you ever, I'll show you, don't do this. No. If you happen to go up here and you want to delete something and you hit delete, and now you're missing something, if you go back into stat and set up editor, it will fix that for you. How'd you do that? But I'm going to show you how to actually clear it out without deleting it here in a moment. So then we're going to go back to stat. And we're going to go over to calculate, so arrow to the right. And then, which of these things do you think we're looking for? Linear regression. So there are two of them, but we want the one that looks more like our y equals mx plus b, so number 4. Don't do 8, just 4. So you can either choose number 4 or go down to number 4, hit enter.
I press enter
Go to stat, go to calculate, hit number 4. I need you guys to focus unless you're helping someone.
Calculate.
Stat, calculate. If you're in stat, it says calc at the top. You arrow over it. Hit number 4.
I hit number 4.
Follow directions on your notes. Then we're going to go down to store regression equation, and this will help us when we have to do things with it in the calculator. And you're going to hit alpha trace. If we would stop talking, we might all hear the directions on the first time. So hit alpha trace. You'll get a list of things. You can choose whatever you want. I just go with the first one, hit enter, and then hit enter 2 more times. If you did not get that to appear on your screen,
I hit enter twice.
Oh yeah.
I
love that. That was the only reason why that is better. Was it? No, exactly.
Oh my gosh. No, it's not. This is one. Yeah, what is it?
I want to go outside.
Yeah, I want to go outside too. Okay. What?
You only get 40 questions a day.
And
sometimes if you delete and re-download the app, then it gives you
Are you wrong?
One time I had a 200 thing in science, and I deleted it. The J-Lo thing. It was 200 questions. Yeah.
Did you get solved right?
I think I looked. I think that like I accepted it.
On the next page.
I don't like doing it.
Waiting on everyone's attention. On the next page, it asks us for a line of best fit. What we write is going to be 3 decimal places. So 6.012, y equals 6.012.
What is it?
On the next page. Plus 53.61. This would round up to 6, so 616.
It's 52 for me.
It shouldn't. So if your answer doesn't match mine, what happened is one of your numbers or multiple of your numbers you typed in incorrectly. So it is very easy to get the wrong equation if you don't type in the right numbers. So be very careful. So Brendan, go back into stat and double check your numbers. Okay. Now I'm going to show you how to do the rest of this in the calculator. Yes, some of this you could do by hand as well, and you'll have that choice. So if we're trying to, please be quiet. If we're trying to predict the grade for a given student who has studied for 0 hours, what variable are we looking for? The grade, which was what variable? Y. So we're looking for y. We have x. So algebraically, you can put 0 in for x and solve this. So that would look like this. Just like our function notation, we would put 0 in, and then our answer would be 53.616. Hasi and Layla, do you guys have questions? No, still talking to them.
Oh, well, I had a question, but it wasn't. If I take algebra this year, then just normal algebra, what comes after that?
Geometry.
It's just geometry?
Correct.
Okay.
What about after this class?
Advanced geometry. Unless you take it over the summer, then advanced algebra. Okay. Yes.
If you did like, if you wanted to do advanced algebra, would you have to do it in class during the summer?
You'd have to do that either over the summer or next year, yes. Okay, refocus. We can talk about that later. Refocus. Okay. Now, for 6, we could put that in, but instead I'm going to show you how to do that in the calculator. So this part only works if you did the store regression part. If you did not do that, this will not work. You go into your table, second graph, then you can find any value. So if I'm looking for 6 hours, then I have my answer right here. So 89.69. Correct. Right on the. Yes.
My calculator says it's sheet.
What?
It just says it's. Like it says it's.
Okay, so go back into stat, follow the directions on your notes. Yes. Yes. Okay. Other this related questions. Eric, focus. Okay, for the last part, same thing. You could set up an equation. since I now have a grade, we're looking for the x. So I would put in 100 where y was. Focus.
He was asking me a question.
Okay, so answer the question and stop talking. You could solve this equation, and then I'll also show you how to put that in the calculator. Subtract that, tell me what you get. If you didn't already in your calculator, do 100 minus 53.616. Everyone should be doing that.
46.384. What's the point?
Thank you. Now divide both sides. And tell me what x is. Say that one more time.
7.714.
7.715. Okay. And then in these problems specifically, you have to think about, could this answer be a decimal? So if I'm looking for number of hours, could that be a decimal? Yes. So that's an acceptable answer. Now on the calculator, we would look at the same thing. So it's asking when it's greater than 100. So I know at 8 for certain, it's greater than, and I could say 8. If I want to be specific down to the decimal, do this. Go into second window, and I'm going to change this to start at 7. And I want to change this to, instead of counting by ones, I want it to count by 0.5. And then I'm going to go back into the table. So change that to 7 and 0.5, go back into the table, second graph. Now I can see, okay, between 7.5 and 8 is where it goes over 100. So I'm going to do that again. I'm going to change it again. Go back into second window. Change this now to 7.5. And now I'm going to change this to 0.1. And see if that gives me a better decimal. So go back into the table, second graph, and then yes. Okay, so now I can see at 7.8 is when it goes over. If I were to keep going, I could get that answer that we found by keep going back and changing that to 0.01 and 0.001 and keep doing that if I wanted to get a more specified decimal.
So what was the top one again?
This one, 7.5 and 0.1. Okay, so that's just to change it. Now I'm going to change it back to just 7 and 1 so that way it doesn't mess up our next table. Okay. When we write our answers, when we write our equation, we want 3 or more decimals. When you do less, your equation starts to get weird and then the numbers you put in aren't accurate. So 3 or more, unless it says otherwise. And then for the answers, if you put 3 decimals into the equation, 3 decimals in the answer is good too, at least. Because that would make it as accurate as possible. Yeah.
How do you change it back to the 7?
So go back into second window and type in whatever number. Yes. Get to the table. Second graph. Okay. So now we're going to do one on desmos. So everyone open up their iPads. If there's anything on your desmos screen, go ahead and throw that off. Yes. Ariana, yes.
Oh, look, it's like.
What number is yours? You're never supposed to be able to exit out of it. Like, close out of it.
Why they think that desmos? I just hate it.
Everyone look at your number, make sure you don't have number 20, and make sure it's not spelled. Make sure you don't have number 20. iPad number 20.
What?
Make sure you don't have iPad number 20. Okay, Brendan, go look and see what number you should have. Okay, you guys have a table on your notes that we're going to use. Did you get yours?
I don't think it's in there.
What number is it? Okay, so in Desmos, you're going to hit this plus. That's how we make tables. And you're going to click the thing that says table. And then in your table, you're going to put in, it's a little blurry, so I'll type mine in. You can type in those numbers. I have to do this on my keyboard though. So 6, 13, 21, 31, 28, 20, 25. 260, 320, 420, 560, 560, 440, and 500. So make sure you have those numbers. So I'm going to show you how you're going to have to do it for me, for the SOL, because yes, they just updated it so you can see this version, but you'll need to do this because this won't be available for the SOL when you go to take it. So, if in general, not saying I believe this will happen, if let's say you had to retake the SOL next year, I believe this would be an option. To click this button, but it doesn't like when I do so. And then you get this option at the bottom, where you can choose which type of regression. We're dealing with linear, so that would be your only option right now. And it would tell you your linear regression equation. Yes. it's like line of best fit. You're trying to find the line that best fits this data, to which I'll show you in a second. Okay. I don't know what to do about that, but it's okay because you're not really going to use it. All of this is in your notes. Now, what you'll have to type and remember, I'm going to get rid of this, is the following. So you know your y equals mx plus b format. It's going to look similar. In your table, you have x1 and y1. So you're going to be using x1 and y1 instead of just y and x. And you're going to type the following. So in your next line, type this. Layla, yes.
How'd you get the thing at the bottom?
We're going to type it right now. So type this. Y1. Then you're going to go into your ABC. And you're going to find the little squiggly line. It's called a tilde. Well, it looks like this. mx1 plus b. So y1 tilde the squiggly line mx1 plus b. Type that in. You should get these numbers. If you didn't, something in your table is off. So double check that. Yes. So double check your numbers. Yes. Go ahead. Anyone else have issues with that? Brennan, yours doesn't match.
Double check.
Okay, I can check yours in 1 second.
Layla,
Layla, yours doesn't match. I can pull this back up so you guys can double check your numbers.
It does, just lay down. Well, now it's the same thing. It's just flip. The M is on the right.
Layla, are you double checking your numbers?
Oh, mine works.
Yeah, the same thing. It's the same numbers, but they're arranged differently. Because the circle thing.
Yeah, the R's on top and the M is on the bottom.
That line thing is.
That's fine.
Oh.
That doesn't matter. As long as the numbers are the same. Okay. Is it still not lining up?
No.
Okay, I'll look at that in 1 second. So when you get this, you're given your M, you're given your B. This is your line of best fit. You're going to type that in the next line. I did not make that correctly. 0.073. Definitely fit that's anyway. It's 168. Okay. Now, you don't see anything on your graph unless you're zoomed out. I'm going to go back up to the top. With my table, I'm going to hit this plus. There's a plus right at the bottom of the table. If you do that, you should be able to see all your data. Now, I did not show this on the calculator just because there are more steps, but I could show you that at a later time. So I hit the plus that was in the corner. It's disappeared from mine. And I can see that this line is either going through majority of these points or touching majority of these points, which makes it the line of best fit. Okay, now if you did not get that, I will check your stuff really quickly. If you feel like you have a good handle on this, I want you to start the next example.
Gilla, this guy. Right there. Should have seen it. Alright. Over there. Exactly.
How do you find it?
Exactly.
So how long is that there and it's not there?
It was up there.
I
She
just
just
drove
covered
it.
it. Exactly. Bro.
I had heard about that.
You were doing I have to drink too. You still didn't hate her. I got green black.
The green math. You know how to green? No, you're the
No.
green math.
I'm still on the example from this, but it'll work the same for that next example as well. Listen. So if I were to find some x value or some y value, let's say I wanted to find when x is 50, I would just type in x equals 50. And then I'm going to look for where do those two lines cross. And that's going to give me my answer for my y value. Or if I wanted to find when y is 100, I would type that in. Y equals 100, and I would look at where does that cross and find that x value. So whatever you're looking for, type that in. Whatever you have, type that in, and it'll help you find whatever you're looking for. So as you start putting this data in, be very careful with the decimals. Now, before you start putting data in, pause. I need you guys to change something on it. So anytime you see something with years, you have to change the years. So the first year is always going to be 0. That's your initial year. Then every year after that is how many years has it been since the initial year. So from 1920 to 25 was 5. Now from the next one, it's still from the initial, from 1920 to 1930. 10. From 1920 to 35, 15. 1920 to 1940, 20. Now in this case, these are counting by 5, so I can just fill that in. But don't assume that always, because sometimes it doesn't always do that. So make sure you're actually counting. But these ones are counting by 5. So 25, 30, I skip one, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. So we are not putting in these numbers. You're going to put in these numbers. Now you can make your table. So as you're doing that, I'm also going to do that up here.
How do you know which year to convert that into? Because there's also years for life expectancy.
So this part.
No, like how do you know which one to change to? Like, you know how you 0, 5, 10. How do you know which one to do it if there's two sets of like years?
So this isn't in. Okay. This is the answer from this. So y I'm never changing. Only x. The actual year itself. Okay, yes. Go on. Yes.
How do I, like, what do I write on the line next to line best fit?
The equation for the line of best fit. In Desmos, if you do have a pattern, so let's say I hit 5 and I hit enter, it will recognize said pattern, and then you can just hit enter instead of typing in all those numbers. But for the y, that doesn't work. You have to type in all the y's. Sorry. Make sure your numbers match, line up. If they end in two different places, you most likely skipped a number. Remember, if you hit the little magnifying glass, the plus, it will zoom into your line of best fit. Get it in. I just want to get this last part. So we got our line of best fit. And then the question asked for the life expectancy in 2010. So how many years? And if I type that into Desmos, I put this up high enough that I can see it. Okay. And look for where those two lines cross. 77.03 would be that life expectancy in 2010. Yes.
How would you get 9?
If we kept going with the pattern, 2005 would be 85, 2010 would be
Oh, so you just kept going.
correct. Now, in this case, we already had like a line that said whatever it was, but you would normally need to put labels, years, dollars, whatever. You have a bunch of other examples. You do have a Delta Math on this. That's due Friday. So you can choose whatever practice you would like. Delta Math, more in this, using the calculator, using Desmos. Remember, you have a choice. Pick something and practice with it. And let me know if you need my help. I will unlock them in 2 seconds. I don't know if that